All right, hi everybody. Doing the seasons lecture, starting off our space unit here. Okay, so our essential questions that we're trying to answer right now are what causes day and night, and then what causes the seasons to change. So we already looked at what rotation and revolution were in our notebook activity that we did on Thursday and Friday. So we know that rotation is the Earth spinning around on its axis. Remember, if we just stuck a stick right through the middle of it, much like this picture is showing right here. So spinning around all by itself doesn't need anything else to be able to do that. That's rotation. And then the revolution of the Earth is its path around the sun, like this picture is showing us here. Its orbit around the sun, and it's slightly oval. We call that elliptical. So we're going to start talking now about what all of the seasons are. So in order to do that, we have to talk about what a hemisphere is. So if you think about where the equator is, and you all know that from geography class, we split the Earth right down the center, right? And we do that horizontally. So it splits up much of North America from South America, right? It's invisible on this picture here. But if we were to split it in half at the equator, above it is the northern hemisphere, where the North Pole is, and below it is the southern hemisphere, where the South Pole is. So we'll talk about northern hemisphere and southern hemisphere quite a bit here to differentiate between the two different places, because they have different seasons at different times. So we live in the northern hemisphere, right about here. So when there is summer in the northern hemisphere, this is the position that we're in. The northern hemisphere, so this top half of the Earth, is tilted towards the sun. You see our axis here? So we're actually tilted towards the sun. We get more of the direct sunlight at the northern hemisphere. It's more focused. And then the southern hemisphere gets more indirect light from the sun. It's more scattered because it has to travel a lot farther and it has to spread out a lot farther around the southern hemisphere. So we're actually kind of tying in some of what we learned about in the light wave section, where we're getting the visible light waves and UV radiation from the sun here, and it's more direct in the northern hemisphere in this position, and more indirect or scattered, which is a word that we talked about, in the southern hemisphere. So here in the northern hemisphere, we have a lot longer days and we have much shorter nights. So it's still 24 hours no matter what, but we're just talking about the amount of daylight that we have and the amount of time that we don't have daylight, so nighttime. So if you think about it, in the summertime, it stays light until like 9:30, 10 o'clock sometimes. And we have a lot less nighttime than we do daytime. And actually, the North Pole, right up here at the top of the axis, is always facing the sun. It never gets a chance to turn around, because as the Earth spins like this on its axis, the North Pole is still always facing the sun. So it actually has constant daylight. There's never a time when it's dark at night. They still sleep, and there's still a time when it's technically nighttime, but they still have daylight. So then as the Earth moves through its revolution, as the months pass, we start to get to a point where we're over here in our orbit, where it's fall in the northern hemisphere. So we're focusing on the northern hemisphere because that's where we live. So whatever it is in the northern hemisphere, it's the opposite in the southern hemisphere. So when we're here, if you notice, the axis isn't pointed towards the sun or pointed away from the sun. So if we were looking at the half of the Earth that faces the sun, which would be, it would look just like this, we're not really at a point where it's tilted away or towards the sun. So both hemispheres, the top and the bottom, are actually getting equal amounts of sunlight. So day and night are pretty equal. We get the same amount of sunlight as we do nighttime. So this would be like in the fall, as our days start to get a little bit shorter than they were in the summertime. It starts getting darker at, 8 o'clock, 7 o'clock. So we actually have about the same amount of daytime and nighttime. And then we get over here in our revolution, and we get to winter time in the northern hemisphere. So here, the northern hemisphere is pointed away from the sun. So when we're looking at this, we really want to look at what the North Pole and the South Pole are doing. That's what's going to give it away as to what season it is. See how the North Pole is tilted away from the sun up here? So we actually get a lot less direct sunlight in the northern hemisphere. It's way more indirect up there. It has to scatter across the top of the globe to get to us. So the southern hemisphere is getting a lot more sunlight at that time. So it's winter for us up here where we don't get as much sunlight, but it's summer for them down there because they're getting more. Just like over on the opposite side, it was summer for us when we faced the sun, but it was winter for the southern hemisphere as they faced away from it. So here, since we have a lot less sunlight, we have a lot shorter days and we have much longer nights. So like now, it doesn't get light until about 8 o'clock in the morning, and then it starts to get dark at 5 o'clock, 5:30. So we have much less sunlight than we did in the summertime when we were facing towards the sun. So here, it's the opposite of what was happening over here. Now, there's always sun hitting the South Pole. So the South Pole actually goes through a little bit of time where it doesn't have any nighttime. It's just constantly facing the sun, even as it rotates. The sunlight is still hitting. So then we get all the way around again, and now neither hemisphere is towards or away from the sun. So it's equal sunlight in both hemispheres. So it's spring for the northern hemisphere, but it's fall for the southern hemisphere. So it's that mild season where we're not really having extreme weather either way. So it's pretty much equal length of day and equal length of night at the equator. It's always going to be 12 hours of each. So in the southern hemisphere, like I said, it's always going to be the opposite of whatever's happening in the northern hemisphere. So if you can remember what it looks like for us here in the northern hemisphere, then you'll just know that the opposite season is happening down there. So a solstice is a certain date when it's either the longest day of the year, meaning we have the most sunlight, or the shortest day of the year, where we have the least amount of sunlight. So the sun hitting us is actually at the highest or lowest point in the sky. So in the summertime, if we look overhead and at noon, the sun is super high up in the sky. But in the wintertime, the sun is actually going to be down closer to the horizon. So our summer solstice happens about June 21st. And then our winter solstice happens about December 21st. So in the summer, we have the most amount of sunlight that we're going to have all year long. And then in the winter, it's the shortest amount of sunlight that we're going to have all year long. So this picture kind of helps to explain what that's about. So up here in the northern hemisphere in the summertime, this is when the North Pole gets that constant sunlight. So down here, closer to where we are, the Tropic of Cancer, we get about 13.5 hours of daylight. The equator is going to be about 12 hours, so it's equal day, equal night. And then as we get into the southern hemisphere, it's their winter. So they are getting less daylight. And the South Pole is actually in total darkness for about 6 months. So winter solstice is the opposite. For us, the North Pole is getting about 6 months of night, and we have much more darkness than we do light. So it's just whatever the opposite was of the summer solstice, but this one happens in December. And equinox is going to be the other main date that we have to focus on. So this happens in the spring and the fall. So this is when day and night are exactly equal at the equator. So the vernal equinox, vernal just means spring, happens about March 20th, and sometimes it's different depending on, the calendar dates where they fall and if it's a leap year or not. So sometimes it's going to be about March 20th, and then the autumnal or fall equinox is September 22nd-ish. Sometimes it's the 23rd. It really just depends. So because it's that both the northern and southern hemispheres are getting the same amount of sunlight for spring and autumn or fall, that's why we get an equinox. It's going to be exactly 12 hours of day, exactly 12 hours of night at the equator on those days. So if you haven't noticed, as we go through the year, as the Earth is going through its orbit around the sun, it's always changing the amount of sunlight that we get and the amount of nighttime. And as we go through the cycle, we'll start out here in spring. So about March or so, we get that equinox where it's 12 hours of day, 12 hours of night. As we revolve into summer, the day starts to get longer and longer, and we get more daytime. It stays lighter a lot longer. We hit June 21st. In the northern hemisphere, we get the longest day. We have 13.5 hours of daylight. And then as it starts to keep revolving, we start to lose daylight. We get to autumn, and then at the equator, it's about 12 hours of daylight, 12 hours of night on the autumn equinox, and then we keep going through winter, and it just keeps getting darker and darker, earlier and earlier, until we hit December 21st, and our winter solstice is when we have the shortest amount of sunlight throughout the day, and then we keep going, and it starts to get lighter and lighter, later and later, and we get to the spring equinox where it's exactly 12 and 12 at the equator, and it just keeps going, and it's just a constant cycle. So if you think about it, you guys have witnessed this if you pay attention to when it gets dark at night or in the morning, and now you understand why. So hopefully we can answer why we have day and night, and we can also work on a diagram of why the seasons are going to change. So we'll do more of this in class. We'll have some stations, and we'll have some more things we'll put in our notebook to help us understand what's going on here with the seasons. So I hope that you guys understood that, and if you were confused about anything, go back, rewatch it, make sure you got all the notes down, and I'll see you in class.